Welcome Year 12s to this video. I'm going to take you through Dijkstra's algorithm, or the examples in your notes for Dijkstra's algorithm, and just talk about briefly shortest path problems and maybe some of the more efficient ways that you can actually solve them. I'm not a big fan of Dijkstra's algorithm, and you'll see why shortly. First of all, this is the first time that we've looked at weighted graphs. So that just simply means that there's some numerical information on each edge of the graph that we come across, or of the network that we come across. So this information most commonly represents a distance, but sometimes it can also represent a time, or say a maximum flow of people or cars or things like that that might be able to get through that particular edge. So with shortest path problems, these are ones where you're given your network and you're given distances between the edges of distances between the vertices of those on that network, and then you need to find the shortest path between 2 points. So it's fairly self-explanatory there. I find that most of the time this method of inspection is actually better. So it's quite often more efficient in small networks. And I do find it even in larger networks that generally by inspection, or if you've got a fairly straightforward structured way of working through the network, this is actually better than Dijkstra's algorithm. So this one here, which is fairly small, it's got fairly small numbers to work with as well. We're trying to find the shortest path between A and between F. I like to circle them just to remind myself of where I'm actually working, of what my aim is. And you'll see that all we have to do when we're inspecting is just check all the possible paths and what their lengths are. So some of the possible paths are, for example, A, C, D, F. So you could go that way. You could also go A, C, E, F. So A, C, E, and then down that way. We've got A, C, D, E, F. You'll notice that some of them, a lot of the time I don't even bother checking because it's quite obvious that they're going to be a lot bigger. For example, this one, A, C, E, D, F. We'll see is quite big. So all we need to do now is have a look through those particular paths and add up their length. So you can pause here and do that now if you like. Otherwise, you should get ACDF as 22, ACEF as 19, ACDEF also 22, and this was the really long one, which I said that you may not even bother because you can see it goes ACE, so it goes down here and then it cuts across and then down this larger one here, the 13. So it's clearly not going to be the shortest one. So then we just have a look at which one is shortest, and clearly our ACEF is the winner. And it says what is the minimum length as well, so that length was 19. Just do make sure you add a unit if you need to, so if it's in meters or kilometers or whatever, just make sure you include that. But I'm just going to put units for now since it wasn't specified. Now that's just by looking at it and checking everything. Sometimes you have lots of different paths, so you don't really want to do that. So a nice systematic approach is using a version of Dijkstra's algorithm, but this is doing it straight onto the graph, which I think is a much better way rather than drawing up a big table. So I'll take you through how we do this. You're going to be writing all over the network, but you're also going to be crossing things out as you go. Basically, once you find what is shortest, you cross out the longer one just so you don't get confused. In each of these, we're going to be working between A and E, so each of the 3 examples that I've got here. So what we do is we start at A, obviously, and then you have a look at where you can get to from A. So I can go 8 units to C, and I can go 16 units across here to B. Then what I do is look at which of these is the smaller of the 2, and 8 is smaller, and I put a box around that. That simply means that to get from A to C, the shortest possible way to do that is 8 units. And I know that it has to be 8 because getting to B is already larger than 8, so it couldn't possibly be smaller. What I do from there is I then work at the one that I just boxed. So I go 8 plus 6 will give me 14. 8 and 9 will give me 17. So you can write the 17 if you like, but I don't really bother because the 16 is already shorter. Then I look at my 2 numbers that I've got here again. So the smallest one is 14, so I box it. And then I go 14 plus 10 will give me 24, so that's no good. I'm not going to write that. 14 plus 14 will give me 28. So if I go that way, I get 28. The next lowest, though, is 16. So just do this box here, so just so I can check that it's not actually shorter to go this way. 16 and 15 will give me 31. I can write it if I like, but clearly this one was the better option. So the shortest path was 28. So if you want to just put your final answer next to it, shortest path was 28. The only downside of this method is you can't actually, you can't see what way you went to get the 28. So you just have to, I guess, backtrack through, and I can see that I went this way. So A, C, D, E. Oops. So that was the actual route of the shortest path. I'll do that again just with the next two so you can see it, but you'll need to practice this yourself as well. I'm starting at A and I'm going to E again. So it's going to be 18 units to B and 21 to C. So the smaller of the two is the 18 over here. 18 and 16 will take me way over 21, so I won't bother writing that. I'll just check the other two. 18 and 20 will give me 38 over here. And then I've got 18 plus the 23. So that'll give me 41. Next I go, what's the lowest out of these ones that don't have a box, or the 21? Obviously I'm not going 21 plus 16, that will take me over 18, so that's pointless, but 21 plus the 15 will give me 36. So you see this one is shorter. Then, now that I've boxed this 36, there's really only one thing that I need to check, and that's whether if I go this way, whether I get less than 41. But 36 plus the 7 will give me 43. So out of these two, it's actually the 41 that was better. And that was going A to B to E. So just summarize that there. And the last one, here we go, A to E. So A to C, 12, A to B, 16. The smaller of the two is this one. 12 and 11 won't give me less than 16, so I'll just keep going this way. 12 and 8 will give me 20. The smaller of these two is 16. 16 and 13 will take me over 20, so I won't bother with that. 16 and 15 will give me 31. The smaller of the two is 20, so I just check this one. 20 and 10 will give me 30, so 30 is the shortest path. So its duration is 30, and that was going A, C, D, E. So whilst on your graph you can't obviously see where you got the 30 from, you have to sort of backtrack to see where it did come from. So that's really my preferred method because I do find it's a lot faster. Dijkstra's algorithm, you have already watched a video on this on Edrolo for your homework, but I'm basically just going to take you through these same three graphs that I've just done this method on, and just do it with the tabular method. The reason I don't like this method is there's lots of room for error. The other thing I don't like about it is it takes much longer to do, and I find that where it would be actually useful would be if the graph was really big. But the problem is that once the graph gets really big, the table gets really big, and so it takes you a really long time to fill out, say, a table that's 8 by 8 or 12 by 12 if you've got that many vertices. So I'll take you through it anyway because I must, it's in the study design, but just know that you don't have to use this method unless you're instructed to. So what we do is we create a table where we start with our, in the first row, so these are rows here, and these are columns across the top here. We start with our beginning vertex, which we're going A to E again. So we start with that, and then what we do is we write every other possible vertex in each column. It doesn't have to be in any particular order, but I find putting your destination at the end is quite useful when we do the last step. So we start at A, we look at A, from A to B, can we get there and how many units? 16 units. then from A to C, it would take us 8 units to get there. We can't get from A to D directly, so we put a cross, and we can't get from A to E directly, so we put a cross. Then what we do, just like I did before, is we look at the two numbers we've got and we put a box around the smallest one. So that means A to C, the shortest distance is 8. And we then move to vertex C. And so you'll see that's why I've written C in the next row. Anything that's got a box around it, you are going to copy that straight away. So that will never change. It's not possible to get smaller than 8, so we put that box around it straight away. Now you imagine you're at C, but remember you've already travelled 8 units. So 8 plus, if we want to get from C to B, 8 plus another 9 will give us 17. Now the thing is, above that I've got 16. So I know A to B, the fastest route is actually 16, because I saw that just before. You'll never write a larger number underneath a smaller one. So I'll never write 17 here because 16 is written above. I write the 16 again. That doesn't mean that C to B is 16. It just means that from A, the shortest route is 16. So you'll write it again. From C, imagine you're here. From C, I can get to D. I've gone 8 units already, so I'll go another 6. So that will give me 14. And then C to E, I can't do just yet, so I'll put another cross. Now, the smallest out of these is the 14, so that means I'm now going to go to vertex D, because that's what's written in this column. Copy anything that's boxed, so I'll do that now, and then know that we've already travelled 14 units, so the one that you just boxed was 14, and so now I'm looking at from D to B. So I've gone 14 plus another 10 will give me 24. Again, I'm not writing 24 because 16 is smaller. Then D to E, remember that we have gone 14 already, and then we're traveling another 14, and so 28. The reason I'm writing this above here is lots of students forget that you've already traveled a certain distance and they forget to add that on. So I'm putting that in there as a reminder that you have to add on what you've travelled so far. Smaller out of our unboxed numbers is 16. That takes me to vertex B, which means that I get to check this last option. Anything already boxed gets repeated. So you see that at the end here, I'm really only checking this last bit, which was 16 units to B. I've got that here. 16 plus 15 will give me 31. I don't want to write a larger number under a smaller one. So I write 28 again. Once you've got your number here that's boxed, so once you get a boxed number in your destination vertex, so in this column, which is E, that was our destination, that means you can now stop because that means you've found the shortest path. So the shortest path is 28. There is a way we can work out how we got 28. What you do is you start with your boxed number that you've got under E and you look above it. So look in that same column and find where this number was first written. It might have been first written here, which is fine. That can happen. But sometimes it was written earlier. So you can see here that it was written above it. So what we do is we draw a line up to where it was first written. The reason we do that is we want to see what vertex actually gave us this 28. And if you have a look straight across and have a look at what row you're in, see how I'm in row D? That means I was at vertex D when I got this 28. So what you do then is you draw a line across to this column that has D in it. So you match the row to the column. And then you repeat that process. So now I'm looking at the number 14. I want to see where it was first written. And it was written just above. So I'll put a line then up to where it was first written. And have a look at what was the vertex. It was vertex C. So then I draw a line across to match column C. And repeat. I'm now looking at the number 8. So I draw a line up to where the 8 was first written. And then, of course, I'm back to where I started because that was row A. So I like to just put a little line across to A, basically meaning that I'm at my starting point. If you have a look at your horizontal lines now, you'll be able to see what vertices you went through to get this 28. So if you have a look at this horizontal line, that's in A. This horizontal line is in C, and this horizontal line is in D, and then of course we got to E as our final destination. So A to C to D and then to E gave us our 28. So as you can see, it takes a lot of practice to get this right, to get it down pat, and it's fairly complicated. It's a lot to it, which is why I'm not a huge fan of it, but I do want you to get some practice with it, just in the event that there is an exam question that asks you to use it. There hasn't been one yet, but since it's listed in the study design, you never know. I'll just take you through two more small ones, and I'll get you to try the larger one on your own. So just again, we set it up, starting at A, we're going B, C, D, and our destination E. So if we begin at A, we're going either 18 to B or 21 to C. Can't get to these two yet. The smaller of the two was 18. Oops. I think I'll just do it by hand like that. Okay, so now we're at B. Anything boxed, repeat. Okay, so next, B to C will be 18 plus 16, but that's not smaller than 21, so I'll write the 21 again. I can get to D now, so it's going to be 18 plus 20 because it's going down this edge, so that'll give me 38. And I can also get to E now because I've travelled 18, but I can then go 23, and that'll give me 41. Smallest that's unboxed is this 21, and that will take me to vertex C. Copy anything that is boxed so that there's less that you need to now check. Keep in mind that I've already travelled 21 to get to C. So here I am here at C, 21 units. So 21 plus the 15 will give me 36. So I will write this because that's smaller than 38. If it wasn't, I would repeat the 38. And then I'm at C, I can't quite get to E yet. So all you have to do is just write the 41 again. Don't put a cross because we have already shown that 41 is possible. So once you've got a number in there, you won't put a cross. Smallest one is the 36, that takes me to D. Copy down anything that's boxed. So all of these ones are boxed. They go in. I'm at D and I travelled 36 to get here. Sometimes writing this on the graph can help. 36 plus 7 will give me 43. So not smaller than 41. So 41 is my shortest path. Just doing my backtracking. Find where 41 was first written. It was all the way back here. Have a look at the row it's in. It's in row B, which means that I was at row B when I travelled. I travelled from B to get this distance of 41 to E. So then we go right across to B, so column B, and we repeat. I've got 18, came from the very first number that I wrote in. That's not going to work. Just like that. And then across from A. So we started off at A, we then went to B, so that was this line, and we finished off at E, so it's just A, B, E, and that was 41 units. So again, not the easiest algorithm, I agree, and I mean, it's up to you what you think is best for you. But you might be able to see why I prefer the alternative method. Last one now, this one here. We'll start off at A. We can get 16 units to B, or we can get 12 units to C. We can't yet get to D or to E. Smallest one is 12. That takes us to C. So we write C. Copy the 12 in. Now you're at C, you've travelled 12 units. So we can go 12 plus 11 will give us 23. That's not smaller than 16, so write the 16 again. We've gone 12 units, we're going to go another 8. That'll take us to 20. We can't yet get to E, so we'll put a line, a cross. Smallest out of these two options is the 16, so that will take us to B. Copy anything box, so these two. Keep in mind you're at B and you've already gone 16 units. So B to D will give us 16 plus 13. So that's going to give us 29. That's not smaller. So we'll write the 20 again. But now we can get to E. I've gone 16 units plus another 15. So that'll give me 31. Now I've got two options. 20 is smaller. So I'll go to now D. Copy all these boxed ones. There we go. I'm at D. Here we are here. And I've gone 20 units to get there. And so 20 and 10 will give me 30. And so that there is our shortest path. Now with this one, when we backtrack, you'll notice that the 30 was actually first written here. So when I look above it, there's no other 30. So I'm not going to draw a line up. I'm actually going to go straight across. So when I wrote down the 30, I was at vertex D. So now I'm going to go across to the column that's got vertex D in it. Then what I've got is the 20. I want to see where the 20 was first written. It was up here. So draw a line up to where it was first written. Have a look what vertex brought you there. It was vertex C. So we'll repeat and we'll go across to C. Oops. If it will allow me to do that. Once you are able to get it, we'll just do it by hand, I think. So across like this, and then up to where 12 was first written, and then across to A. So now we can see we started at A, so that's our beginning point. The next horizontal line was at C, just here. I can see by the label. And then at D. So A, C, D, and of course we went to E after that, and that was 30 units. Okay, what I'll get you to do is try this final one. This is where it would actually be useful to have an algorithm, but as you can see, it gets really big when you start doing this for larger networks. So all I want you to do is have a go at this one. I'll run through the solution with you in our next lesson. What you might like to do is try that graphical method on the network as well to see if you do get the same result. So yeah, have a go at this one, and then we've got an exercise as well. So use whichever method is most preferred for you. I've already made clear which is my most preferred. If you are going to use the table method, make sure that you get plenty of practice with it so that you're not making little mistakes along the way.